Today we are going to discuss arrays, a comprehensive guide featuring multidimensional data structures for complex programming. What are 2D arrays? 2D, often called matrix, is essentially an array of arrays. It organizes data in table form consisting of rows and columns. Structure: data is stored linearly in memory but conceptually represented as grid, rows and columns. Elements accessed using indices, one for the rows and one for the columns. That is I, j. Analogy: there is a spreadsheet for a chessboard where each cell holds dictionary. Facts and examples. Declaration involves specifying the data type, array name, and the number of rows and the number of columns. These serves a required memory. Syntax: data type, array name, row size, column size, semicolon. The row size and the column size must be a constant integers expression or a variables initialized with constants. Example: declaring an integer matrix of 3 rows and 4 is given by int matrix 3, 4, semicolon. Declaring a characteristic for tabular names. Character name 5. Initializing 2D arrays. Methods and best practices. Initialization can be done at a time of declaration using curly braces. C allows for flexible initialization. Full initialization, providing all elements grouped by rows using inner braces. This is clearest method. As shown, we can declare a full initialization. Partial initialization, providing fewer elements than the total size, the remaining elements are automatically initialized as 0. Omitting row size. The row size can be omitted in the declaration, but the compiler must be able to calculate it from the initializer list. Accessing elements in 2D arrays. Elements are retrieved using their unique index combination I and j, which is row index and j in the column index, both starting from 0. The direct access. To access the element at the first index 0, and the third column index 2, m0, 0, 2. Iteration typically involves nested loops and outer loops for rows I and inner loops for columns j. Memory layouts. In C, 2D arrays are stored in row major order, all the elements of the first rows, then the second, and so on. An example is shown. Processing 2D arrays, common operations and algorithms. 2D arrays are crucial for matrix-based computations and simulations. Common operations involve iterating through elements for manipulating organs. These operations form the backbone of linear algebra implementations on data transformations in C programming, such as summation, transposition, searching, etc. Advantages of 2D arrays. 2D arrays provide a simple and effective way to model real-world data that is inherently structured in a grid or a table. Database representation, storing tabular data such as student grades, employee records, etc. Image representing images which the array holds pixel values. Game development, creating game boards for strategies game like tic-tac-toe, chess, etc. Matrix operation, essential for mathematical and scientific computing involving matrices, linear equations, transformations, etc. Between 1D arrays and 2D arrays. The differences, structures, use cases, memory, access. The major differences. Practical examples. Transpose of a matrix. Final matrix is A and G. Its transpose is B are obtained by setting B J I is equal to A I J for all indices the involving swapping rows. Here is the sample program for the transpose of a matrix. Thanks for watching.